Now I'm unmuted. Alright, hello everyone. Why does he choose such random things as his waiting background? That's a good question. I don't know. So, is the koala evil? I guess. So, alright. So remember last time, we were basically talking about functions. And so let's talk about functions again. Maybe not that. Maybe that. Okay. So remember how to declare a function. You declare a function by going def my function, and then you need a colon afterwards, and then basically I'm going to put pass in here. So I think I've talked about pass before. Pass is basically a way for Python to have like a blank line that isn't an error, because if you just leave a function like this, it's not going to like it. It's going to say there's an error with indentation. And the reason why it's going to say there's an error with indentation is because it expects you to implement the function. Pass is just a way to basically just be like, okay, I'm going to put a placeholder, right? This is a placeholder for this position at this tab level. Pass also, it doesn't do anything, right? So the thing is that you shouldn't, in theory, you shouldn't have any passes left in your final code if you submit anything. But I've moved pass from the forbidden to the allowed list last semester because pass really does. I mean, it really doesn't do anything for you one way or the other. So, okay. I mean, and that's the point of it, right? Because basically, if you need something to hold your position at this tab level while you go and do something else, and then you come back and implement the function, this pass will do that for you. Okay, so, alright, but, okay, so other than pass, what can we do inside of functions? Well, we can print stuff, right? We can say print, hello, you have entered my function. You can input stuff. You can say n is equal to int input, tell me an integer. And you can have loops, right? So you can say, let's say for I in range n. Let's compute maybe the nth Fibonacci number or something like that. So if n is equal to 0 or n is equal to 1, we are going to return 1. For I in range n, what we'll do is we'll say current equals 0, and then we'll say, and then the previous equals 0, and so what we'll do is we'll set, and maybe we'll need a total. So we'll say current equals I, or previous equals current equals I, total plus equals. That's a good question. What does return do? So let's get rid of all this crap and just ask, what does return do? So what if we call my function? So let's say we tell it 0 or 1, well, a 0, and so the function exits, but that didn't help us. Let's print it. Remember that return does not print, right? Sometimes students end up thinking that because we always call a print on the return value, but that's just so that we can see it. So let's say we say we return 1, it'll return 1. If we input 0, it'll return 1. If we input, say, 3, then there's no return here, and so there's actually a secret return none here. So we're so actually if we tell it 3, then it's going to give us none. So Yep. So yeah, how do we compute the Fibonacci numbers in a simple way? So remember that the Fibonacci numbers, so fib n is equal to fib n minus 1 plus fib n minus 2. So what we can do is we can always say that, can we print I in the return? No. So for instance, if you return like a print statement, and you say for I in range, let's say n, you return a print of I, what this is going to do is it's going to return the return value from print. And so let's say 5. And so here what it's going to do is it's going to return none. Because as it turns out, if you ever print a print function, so you'll notice that if you ever print a print function, the print function is going to run and it's going to output the hello. But then if you print that print function, which is what this is doing, right? So this printed the hello, and then the result went into this print function, and you get a none out. So you'll notice that that's not usually what you want. So you can't return a print value because, you can't return a print value because it's just going to be none. You can print something right before you return, right? So if you say something like print I and then return I, right? That's okay. That'll return the value I, but you can't return a print. So yeah, I think in order to do Fibonacci numbers, we need like previous is equal to 0, or let's just make previous equal to 1, current equal to 1, and total equal to 0. And so, well, actually, I think we can just keep previous and current, right? And so then what we can do here is we can just say that current is equal to current plus previous. I guess we actually need a temp. And so then we can say that something like this. So Fibonacci numbers are numbers that start a sequence. The sequence goes as follows. It goes 1, 1, 2, 3, 5, 8, 13, 21, etc. And the rule is that after the first two numbers, we just have, so the first two numbers are defined as 1 and 1, but then after that, it's basically the two previous numbers added together. So it's the two previous added. And so I guess here we'll just return current. So this should return the nth Fibonacci number if I'm not mistaken. So let's see what happens here. Let's try to return the 5th Fibonacci number. So depending on how I did the offsets, the 5th Fibonacci number should be either 1, 2, 3, 4, 5, and then maybe 5 or 8. Let's see what pops out. 13. Cool. So I guess it goes to this one. So 1, 1. Oh, let's see. Is it 1, 2, 3, 4, 5? Yeah, it's doing. Really, what we need to do is do this minus 2. Could you skip the values for I in a for loop? If you put I plus equals 3, no. Well, so you remember, yes, you can. So remember what the range object can do for you. So you can always make a loop that's like for I in range. Say it starts at 1, it goes to say 17, and it goes by 3s, right? And we can print out i's. And so let's tell it an integer. Let's tell it 5. Whoa. Oh, right. So it does print out the 5th Fibonacci number 1, 2, 3, 4, 5. So it does print out 5. And then here it prints out this range here. So it'll print out 1 and then adds 3 to get 4, then it adds 3 to get 7, adds 3 to get 10, 13, and 16. So that's something from the range object that you need. And this is totally allowed, right? I've taught this a few times already. And also it's part of for loops and part of range. But couldn't alter the I with code in the loop. No, so if you do something like I is equal to 2 times I plus 1 or something like that, and you print out I, let's say, so here, this is the 17th Fibonacci number again, I guess. And so here you see that so you can't alter. I'm assuming that you're asking because of part 1. I'm assuming that what you want to do is as soon as you find a diphthong, you skip a letter, right? And there are ways to. My hint on that is instead of, you can't force range to skip a letter. So technically, if you want to skip to a while loop, like a while loop, you can do that. So while I in, well, let's say I is less than the length of my string, and then let's say I is equal to 0, input my string equals input, tell me string. And then we can say if my string I is equal to, say, the letter A, then we can say maybe skip the next letter or something, or skip the next 2 letters. So you can say I plus equals 2, else I plus equals 1, and so you can say like new string, I guess, is equal to empty string. So like new string is plus equals my string I. So you can run something like this, and then at the end we can print out new string and see what happens. So what this is going to do here is it's going to skip all of the letter A's. Well, it's going to skip a letter after the letter A's. So if we have like A, B, A, C, A, D, A, A, oh, let's make it less A's. A, B, B, A, C, D, E, A, F, F. So, so this is going to skip the letter after A. So it's going to go A, and then it's going to skip B. So then we should get this B. This is an A, so it should skip. So then we'll get D, E, this A, so we should get F, and what? Oh, this was the wrong input. Okay, that was the Fibonacci input. Tell me integer. I wasn't paying attention. There we go. Tell me string. There we go. So you see here we get, oh, it includes the A's because we add the string on before it does it. Right, so we get the A, and then we get this B because it skipped this A, and then we'll get, here's an A, it'll skip this letter C, so we'll get D, E, and then we'll get this A because we don't skip the A's, we just skip the letter after the A's, and then we have 2 F's, one of them gets skipped. So you can use a while loop like this. There's ways to do it with for loops and flags. There's ways to do it with while loops and indexes. There's ways to do it in all there's like, I mean, like, I don't know all the possible solutions. There are a lot of possible solutions. So this is not a solution to number 1. This is just kind of like a you know, a bit of indexing talk. Okay, so remember that, let's go back to functions for just a little bit. So this function here, so let's rename this function as Fibonacci calculator. And so instead of inputting it in the function, it's usually more common to input it outside of the function and pass it as a parameter. So let's talk about parameters again. So instead of printing my function, what we're going to do is we're going to say input, like int input, you know, tell me integer. And so you're going to be like, okay, I'll tell you an integer. And then what we'll do is I is equal to, let's say, well, let's make it And so then we'll print out the, and so the idea here is that what functions are doing for you is that, you know, maybe you don't know how to calculate Fibonacci numbers, or maybe this is all kind of really complicated and you've just figured it out one time and you don't want to have to keep figuring it out or keep retyping it over and over or sticking it into a loop or something like that. So every time you want to call Fibonacci, right, this should give you, it should do the same thing for you. And that's why functions are so useful, because we can basically call it again and again and again, and now you don't have to. In fact, we can even do something better than this. We can even just say, if you want to call it 4 times, we can just say for you know, t in range 4, and then we don't even have. So this code is really short now, and it uses the Fibonacci calculator, but it also isn't really. So tell me a string. The string is going to be A, B, C, D, E, F, G. And so hopefully it should give us A, C, D, E, F, G, right? It's going to skip A. Cool. Tell me an integer. Let's say 3. So this one should give me 2, I think. If we say 5, it should give 5. 17, it should give that large number. 1597. If we give, let's say, 291. There we go. So you see that Fibonacci numbers grow pretty quickly. B, the whole point of this parameter here. So let me just say, when you pass something into a function, So when you pass something into a function, it's called an argument. But then the thing that gets renamed, so this local variable n is called a parameter. And so the reason why it's called a parameter is because it's the thing that gets renamed, or I'm sorry, it's the thing that either gets copied or renamed, you know, from the original variable. So fint was the original variable, but the value gets copied into n here. And remember the thing about local variables. So the thing about local variables is that a local variable only lives as long as the function lives. So as soon as we reach the end of this function, then this n, this previous, this current, and this version of I, which I think is going to say shadows I from outer scope, but who cares? So previous, current, and I are all going to leave scope at the end of this function. So as soon as we return, all the local variables leave scope. And so what does that mean? Right? What that means is they are no longer defined. Okay? So that's what it generally means. Let me comment this part out because this was just kind of an aside. Okay. So what if we wanted to write our own lower function? So for instance, like a string lower function. You know, that's a decent function to write. I mean, of course, you know, we already have one as s dot, you know, if you have a string, you can always do like s dot lower. But, like, what if you didn't have that function? So, like, other languages, like C++, C and C++ don't always have those functions. There's other languages which don't come with, like, a string class like we have, or they don't come with like a dot lower or dot upper method. So what if we wanted to program a dot lower or dot upper method? So let's say dot lower, right? So how does the dot lower work? So we're going to have the string, and so we want to think about it, right? So what do we want to do? Basically, we want to test and see if we find an uppercase letter. So we want to go through for a character in the string. If character is an uppercase character, so how do we know if it's uppercase? We know it's uppercase if the ASCII value is between 65 and 65 plus 26, right? So that means it's uppercase, right? So I'm not going to use the like IsUpper method, because this is what IsUpper is going to do, right? If you wanted to program an IsUpper method, we could do that. We could say def IsUpper, my character, right? Or, yeah, sure, my character. And so basically what you would do is you would say, you know, you would cut this code out and you would put it in here and you would say my character, then you return true, else return false. And that's really what IsUpper, at least character by character, is doing. So we can call the IsUpper method. So this is not a .IsUpper method, this is just a regular IsUpper method. So for instance, we say, you know, if IsUpper character, then what we can do is we want to add, we want to say our new string is empty. We're going to add something to the new string. What we're going to add is the lowercase version of that character. So we know that the lowercase version of a character differs from an uppercase version of a character. So the lowercase and uppercase differ by 32, which is 2 to the 5th power, so that's nice. So what we can do is we can basically say, take the ord of the character, and then add 32, and then take the character of that character again. And that should do it. That should convert all uppercase characters into lowercase characters. And then if it's not, so this is blue, if it's not an uppercase character, then we just want to take whatever it is, right? So now we're going to return the new string. Okay? So, all right, let's see if this works, right? So let's test this code out. So let's say while s is not equal to stop, what we're going to do, s is equal to input, enter string to lower if I. So we're going to call lower on s, and then we'll print that value out. So there we go. So here I've set up a little while loop, right? I prime my input, as I should do, prime my input. And we're going to go while the string isn't stopped. So technically, we can't lower if I stop. Maybe we'll make it lowercase stop. That way we can lower if I that. So tell me a string. The string is going to be ASDF, so it should be ADF. And then tell me an integer, 3, we should get 2. Tell me an integer, 3, 3, 3. Okay, so enter a string to lower if I, right? So let's enter, hello, I am a string. You know, we don't need those things yet. So let's just do this. Hopefully what this will do is it will give us a lowered string. And you see what it did, right? So it took this letter. This letter was an uppercase letter. And so what it did was it added on to the new string the lowercase version of that letter. So basically, whenever you call string.lower, this is what's happening, right? And so you see that now at this point you can basically write a .lower method. But the point is, like, you know, one's already written for you. It's already part of the string class. So there's no, I'm not saying there's any point to doing this. This is not something that's like useful, at least in Python. But it's always good to know how to do this because, what? Because Python is not the only language out there, right? This class is not just introduction to Python. This is introduction to like programming, computer science, that kind of thing. So this code, if you translate it into other languages, is the right code to basically do whatever you want in those other languages too. So, so yeah, okay. And then let's enter another string to lower if I. So let's just make, you know, blah, 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 blah. Let's hope, see, it converts it. Nice. So the thing is that ASCII, yes, I'm just going to say yes to that. Yes. It's not so much that the other languages like use ASCII, it's that ASCII is like the universal character standard, at least for Roman alphabet keyboards, blah, 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 with all the standard, you know, gobbledygook that I have to say. But yes, ASCII is pretty universal. Yes, that's also correct. When you return something, the idea here is that that function, well, so yes, exactly. So the function lower s, once you call the function, it gets replaced with its return value. That's right. That's right. So like the new string, like the lower string becomes this new string. This is the only way, right? Return is the only way. Well, I shouldn't say that, but it's basically true that a function can communicate with outside code, right? Because as soon as this function is done, now a function can print stuff and you can see it, but it can't give anything back to the original code unless it returns it. And the reason why that's the truth is because this variable here, this new string, this character, all of these things, they all die when you hit the return statement, right? The only exception to that, right, is that like the thing that you return is allowed to live just a little bit longer, right? It doesn't immediately die. It waits until the function dies, and then it gets set equal to the function, and then you can assign it. Yes, that's right. I mean, so ASCII is, in a way, it's kind of a bodged together standard, but it's the current standard just because it's the standard that happened when, basically all this stuff got like finalized. So is ASCII the best possible enumeration of letters? No. Yes. Who cares? It's just a way to map from letters to numbers and numbers back to letters. Can you put a function in Python? The answer is yes, but I'm not going to. That's called local functions, and we're going to avoid that. Is ord A minus ord A equals ord Z minus ord Z? Yes. So if I print out ord A minus ord A, and then I print out, well, actually, if I just did this, yeah, let's just do it the regular. Let's not overcomplicate this, and then, oops. Yeah, exactly. ASCII is kind of exactly what it needs to be in order to get the job done, and who cares, right? So you notice here that ord A minus ord A is 32, ord Z minus ord Z is 32. It's all 0. Okay. Yep. All right. Oh, is that the real Sean Jordan? Sean Jordan. Anyway, okay. So basically, let's talk about multiple parameters. So sometimes you want to pass multiple things into a function. So you can do something like this. My function, say x, y, z, right? And I don't know, maybe we'll make this like a distance function. So basically the distance function, let's say we're calculating the distance from the origin. Then what we can do is we can say, we can return x squared plus y squared plus z squared. And so, this is often kind of a useful thing to do because, your distance, you don't want to be recoding this every single time because remember, the reason for, one of the many reasons for a function is that whenever you call this function, you know that you only have to debug this line once, right? So if you're basically repeating this distance formula over and over and over, and let's say you make a mistake somewhere where you use instead of this, you use a multiplication instead of exponentiation, and you're looking around, and finally you find it, and you're like, ugh. But you know that if you call the distance function, and there's an error in the distance formula, then you only ever have to debug this one line here. And if this line is correct, then you never have to worry about it again. If this line is incorrect, then you fix it, and then you keep calling the distance function. So it's a way to... I mean, it's not the only use of functions. Functions have a bunch of other uses, but really the primary use of functions is to kind of take a piece of code, a piece of functionality, and to basically be like, it does its own thing here, and it really doesn't need to be messed with by anything else. If there's other variables with the similar names, it shouldn't interfere with that. So we kind of just separate that code, and it operates independently, and so you know you can kind of just test out the code. And so that's, it really does provide an advantage. So basically here we have 3 parameters. You definitely don't always have to return. Yeah. So functions don't need returns. But if they don't have them, they're going to return none, by the way. Right? So, yeah, if you just have like a def, and let's say that you have some function that says, I don't know. Well, so the question is, when do you need a return, right? You need a return whenever you need to pass a value back to your original code. So for instance, if you have a function that's like, you know, init server, right? And the init server is basically like, you know, the server address, and it's basically like, you know, server.connect server address, you know, server.init, you know, username, password, server dot whatever, right? It might be that you actually don't need to return anything from this function. Like, if this function completes successfully, then that means that you have initialized your server, and if not, then you haven't, right? So a lot of times a function like this doesn't really need to return anything because nothing here is going to be, you know, is going to be used. So that's just an example. How to write and call functions in other files. Yeah, but not, so that's more in the module section because, yes, but I mean, so you already know how to do that sort of because you know, I shouldn't say you really know, but you've seen the import statement, right? You import this, or you import, you know, I don't know, what a sys, you can import OS, that kind of stuff. So the point is that when you import these things, that's actually taking this. So if we right click on this and we go to the implementation, it's going to open the sys.py file. And here is sys.py, right? Here it is. Blah. Right? All 700 and whatever lines of it. So basically, yeah. So this is what happens when you import sys, is it brings in this file. And this file has a bunch of functions in it that you can call, right? We really only use one thing from it. The only thing we actually use from it is the command line arguments right now. But yeah, there's tons and tons and tons and tons of stuff in here, right? But that's not actually... So let me just say that that's actually not part of functions themselves. That's part of imports and modules, so that's why I'm not talking about it right now. Okay, so... Alright. What do I want to do now? Oh yeah, let's talk a little bit about mutability, just again. So the last thing I want to talk about is mutability. Oh, and by the way, the reason why this is the last thing is I'm probably going to end the lecture at about 1:45 today. I have a meeting. And so the good news is I think actually the one advantage to online teaching is that even though I'm going slower, and even though I'm wasting this time explaining this right now, actually we have these 2 classes that would usually be taken up by just completely exam review and the exam, where you just sit down and do it on paper. we actually have it to do, you know, other things. So, okay. All right. Maybe I'll end it at 150. Let's promise 150 because I always run long, and I'll just go to my meeting late. Okay. So let's talk about mutability. So remember that if you define a function that says like change me int, right, and it accepts an integer, and what it does is it adds 5 to the integer, right? So let's say x is equal to 2, change me int 2, and so we're gonna, return x, right? So we're gonna return the value, and then we're gonna print out x again. So let me show you what happens. So her lectures come out when the her lectures come out when the course, like, they are released. It always says the time that they were recorded, so it always says like days and days and weeks ago, but like they are actually being released on schedule. So anyway, let's do this. ASDF 333 stop. And then I think maybe it'll be next. So, okay. So, what happened here? Right? So, what happened here is that we set x equal to 2, and then we called the function, which added 5 to x and returned it, right? So the return value here is 7, right? But we never set it back into anything. Right? I know this is kind of repeating from last time, but I just want to do it again because it's one of the most tough concepts that we have to deal with when we talk about functions. So notice here that the return value comes out as 7, right? That's what this is here. This 7 right here is this change me into 2. But then we look at the, crap. That's what I wanted. Why would it change? Let's do it again. Okay, anyway, this 7 is change me int of this 2, right? And so 2 goes in here. But remember that for ints, bools, floats, and strings, the local variable, x here, is a copy of the global. So that means that we can modify it, and it won't mess with the original. And we see that here, because here we ran change me into x, we got a 7 out from the function, so it definitely added 5, but then we print the original x and it's still 2. Right? The reason why is because this x gets passed into this function. It's 2 here, but remember it's 2, but it's a copy, right? And so because it's a copy, it goes through here, it gets 5 added to it, so 5 gets added to the copy, and then it returns. So actually, let's debug maybe this print state. I don't know. Let's debug this and just see what happens. Let's see what it shows us. I think it might tell me string ASDF 3. I really just want to see. Okay, so here we are. So it says x equals 2. Cool. So let's go down one line. So we see now that we have a variable x equals 2 right here. Right, so the variable in the function will override the global variable. So, and then let's step into the function. So now we have, and so you notice that here, this x is the copy, right? The x right here is the copy, and then we add 5 to it, and then we return it, right? And when we return it, you notice that x is 2 again, right? And so that's the problem here, is that, well, it's not really a problem, it's a feature. It's not actually a bug, it's just something that you have to be aware of. That when Python takes in ints, bools, floats, and strings, it makes a copy here, So the thing that is done in here isn't modified. So if you ever do want to change something, you have to do x is equal to change me int x, and that will actually modify the value, right? So that will, if you print out x now, it should be modified. That's right. So okay, and then remember that the other case is currently, and so things of this type are called immutable, meaning they aren't changed. But there's an exception, and that exception is if you do lists. And so if we have, say, mylist.append 3, mylist.append robot, and we can return mylist, but actually it doesn't matter, because if you do mylist is equal to a to b3 destruct, then if we run change me list on my list here, and remember I'm doing this intentionally. This my list, well, let's actually call it the big list, right? The global list. And so let's call this on the global list, and then let's print it out. What you're going to see is that it's actually been modified. So let's just run it instead of debugging it. So ASDF. And so what you see here is that lists are not immutable, right? So they are immutable, right? So since lists are immutable, this is actually a reference to the original object. And a reference is basically just a way to say, like there is some underlying place in memory where the object is stored. This variable points to that block of memory that says, this is your list right here. And this piece of memory right here also does the same thing, right? Or this variable here points to the exact same place in memory. It points to this list right there. And so the reason why it does that is because lists are mutable. And so that's the one thing to keep in mind. And when we get to dictionaries are mutable. And classes are mutable. And so basically that's the thing to learn, is that, but this is for the future. Okay. So I'm going to upload this code, and then I'm going to go to my meeting, and that is what I'm going to do. What if a parameter had the same name as a variable? So like if you made, so the only reason why I made this the global list is if I made this my list here, everything would be identical. The only thing that changes is that this is probably more confusing. And the reason why it's more confusing is because you have a global variable that's called myList, and now you have a local variable that's called myList. And that's the problem, right? Like, well, I shouldn't say it's a problem, it's just a feature, right? Like, this variable is the local variable, and this variable is the global variable, and they're different variables, technically. So this variable leaves scope at the end of the function. This variable is a global variable, so it exists for all time. All right. Well, it wasn't 30 minutes, it was 45 minutes, right? 45. Okay. All right, I think that's basically it. Yeah, so I think I've gone over functions basically twice. I think, yeah. All right, I think it's about time. I'm going to change this back to the global list, and then I will git push. Let's see if it goes. There we go. All right. I will leave you all now. Have a good rest of your day.